Hello student, in the last lecture I have discussed about how thyristor conduct. Actually I have discussed about single phase half wave control converter with R load, how it work. Okay, so here I will repeat its operation. So see, this diagram is half wave. This diagram is single phase half wave control converter with R load. Okay, so see, we have discussed already this. At omega t equal to 0, when the supply voltage becomes positive, the thyristor T becomes forward bias. However, unlike a diode, it does not turn on till a gate pulse is applied at omega t equal to alpha. Okay, so when gate pulse is applied, that time thyristor starts its conducting. Okay, so during the period 0 to alpha, the thyristor blocks the supply voltage and the load voltage remains 0. Okay, so during the period 0 to alpha, all the voltage drops only across the thyristor. Okay, so during the period 0 to alpha, the thyristor blocks the supply voltage and the load voltage remains 0. Okay, consequently, no load current flows during this interval. This intervals means during the time 0 to alpha. And as soon as a gate pulse is applied, that means when we apply gate pulse to the thyristor at omega t equal to alpha, the thyristor turns on and the voltage across the thyristor collapses to almost 0 and the full supply voltage appears across the load. From this point onwards, the load voltage follows the supply voltage. That means after the period of alpha. Alpha means when you provide trigger pulse or gate pulse at the gate terminal of the thyristor. Okay, so from this point onwards, the load voltage follows the supply voltage. The load being purely resistive. Therefore, the load current I0 is proportional to the load voltage. At omega t equal to pi, as the supply voltage passes through the negative going 0, crossing the load voltage, see at omega t equal to pi, as the supply voltage passes through the negative going 0 crossing the load voltage, and hence the load current becomes 0 and tries to reverse direction. In the process, the thyristor undergoes reverse recovery and starts blocking the negative supply voltage. Therefore, the load voltage and the load current remains clamped at 0 till the thyristor is fired again at omega t equal to 2 pi plus alpha, and the same process repeats thereafter. Okay, so this is the working of this single phase half wave controlled converter with R load. Okay, so now I will discuss the waveform of this circuit, how it will come. Okay, now see this waveform, this is our supply voltage. Here we consider positive half of the supply voltage. Okay, so this is our positive half of the supply voltage. Time is 0 to pi. Okay, here x-axis is omega t and y-axis is the voltage. Okay, now at omega t equal to alpha, that means at this point, this is alpha. So when omega t equal to alpha, we provide gate pulse at the gate terminal. That means we trigger the SCR. Okay, so see, see here, this is our alpha. Okay, so at this point we trigger the SCR. Okay, so this is gate current. Okay, this is gate current. Here gate current, I have mentioned the gate current IG. So at this alpha, when omega t equal to alpha, I provide gate pulse. Okay, so when we provide gate pulse, that time supply voltage starts flow through the load. Okay, so at this time period, that means 0 to alpha, that means at this time period all the voltage drops across the thyristor. Okay, so when you provide firing pulse, at that time supply voltage flow through the load. Okay, so at alpha position we provide trigger pulse and thyristor starts conducting. Okay, now see, after conducting thyristor, the load voltage is this. Okay, for this is our alpha point, this is our alpha. So 0 to alpha, the voltage across the load is 0. Okay, after alpha we get the output voltage across the load, and the output voltage is like this. Okay, so this is our output voltage V0. This is E0. Okay, E0 or V0, E0 V0 both are output voltage. Okay, and the amplitude of this output voltage is, if this is amplitude of output voltage is Vm sin alpha. Okay, so here we consider this is the supply voltage is Vm sin omega t. Okay, so the amplitude of output voltage is Vm sin alpha or omega t. Okay, so V0 and Vm is nothing but E0 and Em. Okay, now see the output current. So the output current graph is, the output current characteristics is this. This is the output current diagram. Okay, so see here, from 0 to alpha, the current across the load is 0. After alpha, thyristor turns on and current flows through the load, and that's why after alpha we get output current. Okay, now see the terminal voltage. Terminal voltage means voltage across the thyristor. Okay, so see when thyristor, when there is now see this curve is this is the terminal voltage curve. Terminal voltage means ET. Okay, so see, when thyristor does not conduct, all the voltage drops across the thyristor. Okay, so see, in between 0 to alpha, this point is our alpha. In between 0 to alpha, this is the terminal voltage graph. After alpha, the supply voltage, thyristor starts conduct, and the current flows through the resistor. So here voltage is 0. Okay, the terminal voltage is 0. Okay, so when thyristor does not conduct, we get the terminal voltage, but after providing firing pulse, thyristor starts conducting, and at that moment the terminal voltage is 0. Okay, and see, and this is the this graph represent the positive half cycle of the input voltage. Okay. Now see, when negative half cycle goes on the thyristor. So see, during the negative half cycle of the supply voltage, the cathode terminal becomes more positive with respect to the anode terminal. Okay. As a result, the thyristor gets reverse bias and blocks the negative half cycle of the supply voltage. Okay. So when during the negative half cycle, the thyristor, the cathode terminal becomes more positive with respect to the anode terminal, and the thyristor gets reverse bias and blocks the negative half cycle of the supply voltage, and all the voltage drops across the thyristor. That's why the terminal voltage is like this. The terminal voltage graph of negative half cycle is this. Okay. So during the negative half cycle of the supply voltage, the cathode terminal becomes more positive with respect to the anode terminal. As a result, the thyristor gets reverse bias and blocks the negative half cycle of the supply voltage. Thus, the voltage applied across load becomes 0. Okay, and in this way, the single phase half wave control converter operates. Okay, so here in this lecture, I have discussed how this waveform come. Okay, so here I have mentioned the waveform of output supply voltage, gate current, current, output voltage and terminal voltage, and how they come in this manner. Okay.